which you come across integration. So why to make a integration program as a part of your program, but you can attach as a function or subroutine. That means a additional program to your program, and these can be compiled separately and then linked. And so because integration is can be used anywhere, so you can put that program separately, attach this. So this is the advantage. And no variable in the function or subroutine. There are two ways it can be done. The one is known as function and another is known as subroutine. Let us understand. All major computing language allow complex and repetitive uh, programs to be broken down into simpler procedures, each carrying out particular well-defined tasks, often with the different values of their arguments. So let's see what is this. In Fortran, these subprograms can be called as a subroutines or functions. Example, for example, now you want to calculate the distance r, which is, you know that if you are given the coordinate x and y, so it's nothing but a square root. So every time typing there for calculating at various step distance, it would be better to use a function where you put this root x square plus y square separately, and whenever you need to, you can use it. So now then also, like if you have to calculate factorial of any quantity. Now factorial of any quantity is a general thing that you would like to, like if you want to calculate NCR. So you know that NCR, how to this is the how to calculate it, but it will involve the factorials. So why to make many times the same thing in your program? This can be avoided by attaching to the program this little program for distance or little program for subroutine. In a bigger prospect, like if you use many integrals when you evaluate, you have got so how will you use it? Make a simple program, but that would be a little higher level that we do, but you can understand an integration program attached with function. Okay, like you should have integral where you can just change the function. Sometimes you want to calculate sine x, or sometime x square plus 1 into, total 1 into tan x. So if you have a ready-made program, then Simpson rule that I told you, you just give the function and it will give you the integration done. So this is the idea about the subprogram. We call it subprogram, and or function and subroutines are these in Fortran. For example, this is intrinsic subprograms. Certain subprograms, intrinsic subprograms, are defined by the Fortran standard and must be provided by an implementation of a standard library. Like I told you, square root x, best example is sqrt x in the bracket you are giving. Now, how to calculate square root x or exponential? The exponential can be, we will come across that. It's a series that you calculate, but you give exp in the bracket x. So these are the intrinsic functions or the built-in function. You don't have to, calculate yourself. But little above that, like I told you, Simpson or factorial n, these are not available as a, because these are not normal function, but all the tan, sine, cos, all those functions are. So there are already many functions. You have simply to put in the argument here, and then So it's a yx square root of x. So it's a x into square root of x. So you don't have to, a computer does not know how to calculate the square root x. So what it does, a program is already available in all the Fortran package that it can calculate the, so you give the argument, it calculates and brings it back. The same thing we will do with the function, that we will give whatever calculation, like you want to do integration, give the limits and the function should be given in the function part, and then it will give you the result. So in main thing is that in main program, if you want to terminate your program, you use stop. Stop means altogether computer will stop your program. But when it goes in the function, it simply calculates the value and returns where you have. So like this is one of the steps. Square root x is calculated and brought back here and then proceeds. So similarly, you will do for the function here. So what we find that the program, one is the main program, another is the subroutine. You have to understand the different way, and the modules. So modules is not, in your syllabus. So, but anyway, these two will take up in higher classes. I take modules as well. So let's see that how we can use these subroutine and functions. So main program, as you know, that will be a main program, and then now subroutine, how you want to calculate with this. So in calculation, how you will do that, you will wherever, like here, I simply wrote square root x here. Now here, but for the subroutine, you have to do something else. When you are using subroutine, so you will say call name of the subroutine. For example, if you have doing integration, you want to name it. So its name is arbitrary. You can name anything to, but you have to have spelling also, call, subroutine, and name of the subroutine, because it's not necessary that you have only one subprogram. You may have 2, 3 subroutines, 2, 3 functions, 4 functions, 5 functions. So you have to, so you will call subroutine and name of the subroutine and the arguments of the arguments means what are the values you would like to send to this subroutine to be utilized, and also it will return. So there will be separated by comma some values which will go into the subroutine, some values which are calculated in the subroutine will be coming out, and then out of this list you can use the calculated value in your further calculation. So that's the idea in this subroutine. So now you should remember that if these are now how it is utilized, that I should tell you. Now what is the function? So here I am telling you how will you use in the program. I have not told you so far that how this program will be. Like a function, it's similar, exactly like a square root exponent. So you make a function and write, for example, distance, radius xy. So inside you can go write the radius equal to square root x square y square. So x will come from here, y will come from here, and wherever you have used, you simply use radius. So that will be, now you can put a, b, 4, 5 or 6, 7, whatever distance you want to calculate. So the difference with the intrinsic function and your function is that you can create your own program, and which is not available in the computer. So wherever you want to calculate distance, so simply give the value and write radius. So this is, so you have to make a function program, and you have to tell that name of the function, and name of the function is radius, and then argument. Let's see further restrictions on a function should be used when a single value is to be calculated. As you can see that in subroutine, we can have list of the values I said, like you can calculate if you give a couple of things and it can return, like if you give the distance and time, you can calculate velocity, acceleration, and so on, and that will be calculated given will be returned by this, and that you can use. Here the disadvantage, or you can see that you can use function where you want only calculate one value. Now module is the, I will just introduce but not go in detail. Functions and subroutines may be internal, that is contained within only. So like module is can be used for a single program, while when you give the module, it can be used by the various part of the program. So it's a general sort of, so how you, that means this is wherever required, it can be used. So you write one and just say something. So use module name, just say this, then it can do the. Now let us see the structure of the function. You see, now I have to calculate distance. So I have, here is this suppose little main program, and then so program example. So you write implicit real, if it is real, xy declare it, real radius is also, then print input, or you first, so it will print as such, print star in the quotes. So it will print on the terminal this. So give read xy. So you can give the value of x, or you can read and write a statement. You can use it and give it in it. Now you write, simply write print, like you could have written square root x or square root x plus y in the bracket. So here you have created a radius name function. So you write radius xy. So simply it takes the value of xy and returns the value by its name. Like a square root, you write, so you have utilized, so wherever you want to use this program, simply write radius xy, radius 3, 4, it will go. Now the program is something like this. You have to declare, now this is the thing that is here. The exactly same thing you have to write here. So real function. So you will write real function. And here you see all the program is top, end, and then you will write out of the main program real function radius a comma b. So these are the argument, function name. Now you have to tell the nature, whether it is a complex function, integer function, or whatever. So you declare here what type of function you have made. Then remember that this argument is the same thing that is brought by here. Now you might think, why I have called A and B? Well, computer does not know what is the X or Y. Simply it knows that something written here corresponds to the something written here. The first argument, second written. So it automatically takes the, suppose I have written 5, 3. So here automatically A equal to 5. B is equal to 3 is taken, and then you have to tell again real AB, exactly whatever you have to declare here, like XY corresponds to the AB, radius. Now here is the function that you are writing, radius equal to square root, and then return. I have not written return, so you may write. Nowadays in some program, if you don't write, it's fine, but some of the program you will find that if you don't write return, that means where from this was called return. So after this is coming and comes here. So it takes the value AB through the argument. So you transferring your values XY like here. Now here XY not necessarily be variable. You can write 3 or 4, but here you cannot write 3 or 4 because it has to be variable. here the values are transferred, so you can take a variable here. And then it substitutes here, does it. Now, end, you cannot write anything on your end. You have to end the program by radius, because so that the function knows it. So, and then return and end. So it takes the value a, b, calculates it. Now, wherever you want to use at other places in the further program, you simply write radius xy. So like square root x or sine x, or so whatever you write in the argument, but there in the built-in function, you can't write two things. So although you calculate mod, for example, so there you can, but you have to make such function. Now let us see the same job you want to do by subroutine, then what will happen? So you saw in your main program, you have to use that function as such. Then at the end of the program, a little program known as function. Here what you do, like same thing I will do. So like real xy, radius, input xy, print, same thing. And you see call distance. Here I am calling distance. So call distance. It's not you have to not write call subroutine distance. No, call distance. Name of the subroutine. Then x comma y. So x and y will be transferred and radius will be calculated in the program and returned to you. Then you can use radius further on. And here, wherever you want to radius, you have to use in the expression radius xy. So here you can see that the program x comes here, y comes here, and radius comes here. And then correspondingly, so now it doesn't know this is variable is not known here, not known here, but you can write real AB and this thing a square, b square, and calculate it and just return. Here, not necessary that you end the program by name of the program. So you can see that here I can calculate R and write R, S may be a fourth root of this quantity. So then I can write R comma S, and here I can write any variable radius 4. So where fourth is square, so it can return you two values, which so you have to just pick up from here and use your here you have here also you have to write. So what are the main difference you can see here? That this program returns only one value, while this program can return. Now here when you are using the main program, just use the function. Then how to write the function? You have to write real function and name of the function, and end the program by the name of the function equal to something. Here it's very different. You can here you have to write subroutine and here call. So when you call distance, then it understands that distance must be a subroutine. Now distance cannot be, distance is not a function here because you have used call here. So it's a difference. Now in function, you can input as many quantities as you want, but it will not return anything. Remember that don't change this. So what will happen when it is calculated, it will come back. Nature of the function or all the arguments used in this program can be used. You can take the same variable over here and here, there is no difference. There is no difference. This is something different. This is entirely different program than this program. And similarly here, anything like you had defined here, a is equal to 5. And then you created a here somewhere. And that a has nothing to do with this. The only thing matters is the argument which are common should be the same. And you can't use like a real argument here and integer argument here. So this is what you have to care, that any dimension use for this quantity should have also the same dimension. Otherwise, computer will tell you these two quantity not compatible. So it's depending on what error they have named it, so it will tell you the argument mismatch. So you have to be careful from that respect. Let's see that how you can make a power series program. It's a simple e to the power x, although it is a built-in function there, but I tell you how the computer takes it. So they have made some simple function, they have made the program and fed in the computer. So for example, that I have a main program, open unit x, I want to calculate e to the power x 0.4. So then I define this sum term, there are each term here, so I define term, each term, and total sum is sum. And both is start, so I don't, because this is 1 and rest of the values depend on x. So I say that start sum from here to here. I take the sum as first term is 1, sum 1, and then you can see that this term is 1. So I can generate other function by using do loop and multiplying this by every time it comes. Like, you know, it's a factorial 1. It's a factorial 2. So 1 into 2, 1, 2, 3. So if I multiply this by another x and the 2, it will then another 3 and 3. So it will automatically take other values. So that's what I'm doing here. Term has been multiplied by x, float n, because n is integer. So I make it real n or float n, and then I check it that the term becomes 10 to the power minus 6, then I stop this do loop. So here by anticipation, I can give 500, 600 or something. Why I should give here something? Because maybe it's not possible that this term is going to converge. So it will do 200 times and then terminate it on its own because the do loop is only. So you can see that in this way you can make a program and then continue it. Now here you can feed this as a program. You can feed this in a computer as a program. So such programs are required in the now similarly without do loop I can do the same thing. As I told you that here I check this, and if this term is less than then I return it to go to this point, and then I go on doing this way. So this is just one example. So let's go back. Make a function program and subroutine program. Let us see that factorial n. Now you have to see that how factorial n can be generated. Now any number, first you have to have a thought process, how you want to do it. I know that if you want to make the factorial n, then better make the factorial n is something like the TER is equal to 1, do 15i, 1 to n, and 15 here. So, you know, the factorial 1 is nothing but you make 1 multiply 2, multiply 3, multiply 4, and if you have a 5 factorial, so do loop up to 5, so it will, and start with 1. So multiplies 1, 2, 3, 4, 5, and then gives you the fact. So you see, I have created a fact n. So function here, normally, if you, nowadays computers are, little particular, so you can use real function or just write function. Something straightforward like a real function you don't have to declare, and sometimes some computer require it. So real function, fact is the name of this, and then I can generate the factorial and return an end. You see, I have used here like how to calculate the 0.4 and term 1. and sum 1. So I am doing now what I am doing in this program, rather than multiplication trick, I just straightway calculate this function. Calculate this function. So you can calculate this function and this function only if you know the factorial. So I say, I'm not going to think too much. I simply evaluate this and make a factorial subprogram. So this is what I'm doing. I don't worry. I would like to make a program. So what I am doing is I name the fact n is the factorial. So like here, if I say that, yeah, I know that I just say that there is a factorial subprogram. I just call 1. It gives me factorial of 1, 2, 3, 4, 5. So I made a program. And then I'm doing the same thing here. Now I wrote the first term is x and multiplying n here. And you can see simply I'm dividing by factorial. Absolutely the same thing. I don't care. X divided by its factorial power 2 x square by. I just want to make a power x to the power n. Each term is like this. I check this term and do this. So you can see that how factorial subprogram has been used here. It's just like your program is like a built-in sine, cos, or tan function. So this is the advantage, because I know that every time this factorial is required, so I better make a program. And why to do trick here? Suppose you have to write minus x, so alternate sign will be minus here. So if you have to do something, you can do here. Now, if I want to do, some people might be interested not to make a function program. They would like to do it by subroutine program. Then what would be the difference? You want to calculate the e to the power x at 0.4. So give this term 1, sum 1, let's see. Now I am doing the same thing, giving n and FACTON will be the factorial. So it is returned here. So if you look at this part and look at this part, so you can see that it can calculate factorial here and the factorial same way. But here I have given n and this subroutine gives me back. I might have used something else also. So two values can be obtained by me, and that I can use in the program. So this part differs here, this part is the same. Now here you have to return by name fact, you can see, and return it. Here you are not using, simply the same logic is used, and like result and rest. So here is this written the value. Now here I think I should have written RESN. So I just write RESN is returned here, and that corresponds to fact. So the same thing I could have used M here and did everything with M. It doesn't matter. The only thing it requires that if it is integer, it should be integer here as well. So you see, this is the major difference between the subroutine and the program. So that you can. Now I ask you to calculate NCR. So you know that NCR can be calculated. NCR can be calculated by the this. So if you write NCR, that is factorial n divided by factorial n minus r and factorial r. Now you have to calculate, make a program. Now this is also a standard subprogram. So like you can make a subprogram separately, that these values you will demand and these values you will return. So like somebody has to calculate in his program NCR. Earlier I have made a function for the factorial. Now here I am thinking to, now here why should I waste time and calculate factorial n and factorial n minus r, where there is a danger also. This r is the same, this r basically is a capital R. Now this might go 0 sometime. So what I'm doing, what is factorial n? Basically factorial n is n into n minus 1, n minus 2, and so on, it goes to 1. Now what is factorial n minus r? Factorial r is 1, 2, 3, 4 up to r. So this term, you can see that you can cancel the term from here, that part. So this basically is that you can make n into n minus 1, n minus 2, n minus r plus 1 and factorial 1 to r. The rest part is the same of the factorial n. So it will pass n minus, like it will take 6 and then 2, 6 C2. So you know n is 6. This is 4 factorial and it is 2 factorial. So 2 factorial, let it be there. Now this factor out of 6 will be will pass the factor 4. So up to factorial 4 you can cut down, delete it, and then start from here. This is the strategy of the program that I would do while making the NCR program. So I need to calculate basically this and program it. Okay, so read the n and IR. Now R is, is a real in Fortran. So I just multiply for convenience so that it becomes integer. So IR, but I write IR so that I'm sure this is nothing but R. You can always add anything so that or declare R as a integer. So I start, term is 1. I have to do this function. Do 13i. You can see that this function is basically calculated from here to here. So n minus r plus 1 to n. Just do loop will start here. And then it will calculate this term. And here float I. So term divided by float I. So that means that the term, I have created 2 terms. So term 2 is 1.0. So I make a program that the one term will be going from here to n. So this variable will go 1 by 1. So I will multiply them. So term 2 is 1. So it will create all those values and multiply here. Now here I have used the same variable here I and same variable I, but they have terminated separately. This I think should not be done. I could have taken a variable j, that is better. Then I have calculated term 1 will be calculated and term 2 will be calculated. So while this job is over, because this job is over, I can use the same variable again. So on the other hand, so there is nothing, no mistake in this. So first I calculated this as a term 1 and then separately as a factorial here. So I can just say that if NCR is there, I can make a function where you give the value of n comma r, and then you can calculate the NCR as a return value, or you can use a subroutine. So you can see that these are the tricks that you would require. The arguments in the subprogram statement are called dummy argument. That's what I said. It doesn't matter. You may write there R and X and Y. In other you can write P and Q. So they are dummy argument. They exist only for the purpose of defining the sum program and have no connection to other variables of the same name in the other program. The advantage of this is that you can make a little program, sub-programs, so that you have choice. Otherwise, you have to make always see that some variable have been defined, and that should not be defined again. Otherwise, the new value will be taken. So the arguments when the subprogram actually invoke are called the actual arguments. They may be variable, constant, or expression. As I said, you could also write in the argument 30 plus x or 2.0 by y. But this is only when you are using the program in the main program. But you can't write this in the program. But so whatever will be there, if it is equal to in the program, subprogram, so that you can write P. So this calculation done and will be taken P. And this calculation can be taken as Q. So that's what I told you, that you can't take constant value. For example, in the radius, you could not invoke radius x, too few arguments, or radius 1, 2 arguments of the wrong type. Means you cannot write, as I told you, in the function. There is another interesting part, that something is a dimensional quantity in this program. So both should be dimensional quantities. So arrays can be passed in the program. So like you have given x is equal to 3 dimension or real x3 there. And you then in the argument, you don't have to write x3. Otherwise, only third argument will be passed. You have to write x so that all the values will be, and nothing should be written in the bracket. So whatever you are doing in the nature, if it is a dimensional, that should also, and declare immediately. So all the three values will be available to here. But if you write x3 here, then only one value will be transferred, remember. So like subroutine is geometry, NDIM value and x. So you can give the dimension by itself, that whatever dimension you use here, NDIM is something, then dimension can also be passed in this way. You can define the dimension. To avoid errors in array, dummy arguments should have the same dimension and shape as the actual. But also that you cannot use, if you want to use, for example, y, you could use y, but then dimension make in the subprogram y3. So it forgets, it knows that the whatever was in the main program x is now y in this program and has the same dimension. Declaration, as I told you, if there is a real thing defined in the main program or complex or whatever, the same thing should be done in the subprogram. So the values which are, so this is simply, so finally, that what are the differences in the first difference? Function starts with the statement function followed by the name of the function and its parameters, arguments. It starts with the statement subroutine, the name, followed by the name of the subroutine and its argument. Function is valid while function area is invalid. Like you cannot use in your program here you can say that subroutine area or subroutine x. You may give argument here, or you may use any other method to give argument there. Like I will tell you common. So here you have to give argument exactly what is there. A function evaluates and returns only one value to the program. So if you think you want to calculate only one, better use this. And why to make a bigger, okay. It may return any value at all. for example, we can write a subroutine to print some messages. You can, by giving RH, you can calculate volume, you can calculate, pi RH, or whatever you want to calculate, you can calculate and return back. Here you cannot do. You can calculate only one value. A function subprogram is called when name of the function alone is used. A subroutine is called by the statement call something, and then name of the function subprogram determines whether it is an integer function or. So if you have decided to name something, so it should see that that function should return integer if you are doing the integer function, or it should return like a real value. So depending on the argument in both, your subroutine has nothing to do with, you can use whatever you like in the program. So these are some examples like call subroutine. Here you give the argument, here you can write 120, but you can't write 120 here, because so A corresponds to array and n corresponds to n, and the n value will be taken 120, average corresponds to this. So in subroutine, and you can see that a real, integer, whatever is there, I have declared those here as well. So there are many examples. Now I told you that I should tell you that you can use many subroutines and put at the end of the program. Many students put at the beginning of the program. Well, you can put anything outside, but sometimes it is better not to, because main program, anyone would like to read the program should see first the main program and see where sub programs are. Sub students have got the bad habit, they put sub programs in the beginning and the main program at the end. It looks ridiculous that what you are doing, although it's not incorrect. So you can use as many subroutine, as many functions you want in your main program and list them at the end. There is no preference of the listing that you found, you called first function earlier than the second function, but you can put second function anywhere according to your choice. You can put, there is no sequence involved that if you have called the first subroutine first and then second, so you put the list. But a logical way, looks always good to write in a sequence. So these are the function. Two functions are, you can see, one average and fun. Now you can use inside a function another function. Like you could use for integration, for example, if I need factorial n, so in my subprogram subroutine, I can use the function. It's not that the main program can only use your subprograms. Many subprograms can also make a subprogram. The only thing you have to write external function so that the computer knows that you are calling the external function. Okay, so modules, as I said, let's not do it. If you have any question, so let me know.
Sir.
Yeah.
Sir, what is the advantage of using the subroutine or function?
Yeah, the main advantage is that I told you that like factorial n. So if you are making a program and factorial n is used, or let us say at various places this factorial n is coming. So you have to make that part of the program 4 or 5 lines again and again and again and again. That's not like here you want at x is equal to 0.4. Somewhere you want, for example, in NCR, you need to find out at n and r and n minus r. So you have to repeat this function of factorial program 3 times in your main program. So it's better to make a subprogram. Whenever you require, you can get it. Is it clear?
Sir, actually means my question is why should we use one over the other? Because subroutine can do all the things that function can do. So means why there should be two things like one subroutine and one function? My question is
because you have to make a, function is a very simple program. So subroutine, you have to call subroutine, and function it just goes into the expression without any problem. So it is inside, while you have to call this and then you get in the argument, then put that value. So two statement, while if you use function, it's a one statement. You just use function as such like you are doing. So like if I have, you see, if I have to use EX, I just write EX minus EX here. So otherwise I have to call subroutine any name, EX, PX, something. It will call and then from the argument put then here. For the another value I put here. Its exponential is different, its exponential different. So making a mess, rather simply make a function which calculates EX and write it. Okay. So, but the only this function is preferred when one value is to be returned. So many people do it. Okay.
and so any time lag means like subroutine is more faster or function is more faster, something like that. While memory access and all.
More nowadays faster little you will run your program is by the time you hit return or enter the program has run. So nowadays this is not an issue, but certainly if there are two statements, so two statements will take more time. And also I said the program should be clean and beautiful. Like here, you could okay, let me go to this. Yeah. Now I could have done this thing by factorial n and factorial put n minus r and factorial r and then calculated it. So why should I? But when you make this type of style, so that means you are alert, and this will certainly require. So one time, however, for this you have to be clear that because I am cancelling n minus r factorial through out of n, because both will terminate to 1, it will pass n minus r. So these things are trick and attractive that makes you feel happy that it's not like a lazy person you are doing. So I said, if you want to be lazy, just make a factorial program and put this value. Two statements are required only. You just write sum is equal to make a function program factorial, give n value n minus s, so fact n minus r, fact r. It will give you the answer. Is it not? But then you made a sub program. So this is all that matters. Okay.
Okay, thank you.
Anyone else? Okay, maybe you have next class. So let me terminate. Like you have these things now, so you can make a program now. So I think we have done almost a lot of programming. So all the statements are there. Then there are many more statements that we will be using and telling you those. So this is the preliminary sort of thing. So in the next lecture, I will see some next thing, a couple of things, and also complex function. Okay, then bye. And I'm ending the meeting. Okay, try to download this. I will send you by email.
So send it for Ubuntu too.